Okay, come Mariam. Exercise on lesson 2. Choose number 1. Try to read the answer.
Okay, the answer is C2H4O.
C2H4O, excellent, because we are going to make simplify by 2. So will be 2C2H4O. Okay. Question number 2.
The question number 2 will be 2. The number of empirical formula will be 2.
Will be 2, excellent, because we can make divide by 2. So the number of units, K equal to K. Number 3.
Number 3 will be C4H8.
C what?
C4H8.
C4H8, excellent. Okay. Have you calculated it and there is no problem?
Yes, I will calculate the molar mass for CH2.
Yes.
I will difference the empirical formula.
Yes.
Then I will get the number of
units. Yes.
Then the formula. Then the molecular formula will be 4.
Excellent. Excellent, Mariam.
2.
Excellent. Okay. Question number 4.
It will be C3H4O3.
Excellent. Excellent. C3H4O3. Okay. Question number 5.
Question number 5. ما عرفتش احلها بصراحة، دي وقفت فيها.
Why? Empirical formula of CH2O. Question number A. Number A, CH3COOH. So, what is the number of carbon atoms in this compound?
2.
Hydrogen?
4.
O?
2 برضه.
Excellent. So we can make simplify by 2.
Okay.
Will be CH2O, right?
Yes.
Try to make simplify for answer number B.
Okay.
Will be what?
CH2O.
Excellent. And answer number C?
Okay, I understand it. أنا فهمتها خلاص.
So the answer will be? Yeah, so the answer will be what?
Number D. All the
number
previous.
D. Excellent. All the previous answer. Okay, Mariam. Question number 6.
It will be CH4.
CH4. Okay, excellent. Have you calculated it well?
Yes.
Yes, okay, okay. So, question number 2. Write scientific term. Number 1.
Number 1 is chemical reaction.
Chemical reaction. Okay, number 2.
The mole.
Mole. Okay, number 3.
Avogadro's number.
Avogadro's number. Excellent. Number 4.
Molecular formula.
Good. Number 5.
Practical yield.
Yes, as he said, practically. So, practical yield. Okay. Number 6.
Molecular mass.
Molecular mass. Good. Number 7.
J-Lussig's law.
Excellent. Number 8.
Avogadro's law.
Avogadro's law. Lovely. Number 9.
Empirical formula.
Empirical formula. Excellent. Okay, number 10.
Theoretical formula.
Excellent. Theoretical, because the amount of reactant we expect. We expect. So, with the word expect means what? Means theoretically. Okay. Question number 3. Number 1. It's very easy, I think.
Yes.
Molecular formula of compound containing 85.7% of carbon, so it's a mass of carbon. And 14.3% of hydrogen, so it's a mass of hydrogen. Whose molar mass is 42. So we are divide the page into 2 lines. Line number 1.
Yes. represents
hydrogen. Now line number 2 represents carbon. So we are going to make what? Okay, try to explain.
We will make the ratio. We will like the weight of hydrogen 14.3 and the one of carbon 85.7. Then we will make 14.3 divided by 1, and we'll make the carbon divided by 12.
Excellent. So the simplest ratio will be what?
Will be the first one 14.3 to 27.1416, then 2 to 1.
Yeah, excellent. B will become 2. So the empirical formula will be?
CH2.
Excellent. So try to get the molar mass of empirical formula. Equal what?
The molar mass equal 14 gram.
Excellent. So what about the number of units? How can we get it?
It will be 42 over 14. It will be 3 units.
Excellent. So the molecular formula will be?
Will be CH2 times by 3. It will be C3H6.
Excellent, Mariam. Excellent. Excellent. Lovely. Okay. Question number 2.
I will get the mole of sodium chloride, then
Yes.
the mole of silver chloride.
Silver chloride.
Then
yes.
I will make the practical yield, then the theoretical yield.
Okay.
Then
practical
the percentage yield.
Yeah.
Will be 140 grams.
Yeah, excellent. So and theoretical?
And the theoretical will be 143.5 gram.
Yes. Okay.
The percentage yield will be the practical over the theoretical times by 100.
Yes.
It will be 97.56.
Okay, excellent, Mariam. Excellent. Okay. Question number 3.
Question number 3, I will get the molar mass, then the mass of
molar mass of iron carbonate. Yes. Equals what?
It will be 56 the molar mass.
Yes, molar mass of iron carbonate equals what?
116.
Yes. So after that,
I will make the mass of iron in 1 mole.
Yeah.
It will be 56 gram.
56 gram. Okay, excellent. So
then the weight percentage,
what about the weight percent?
It will be the mass over the molar mass times by 100. It will be 48.26 by approximation. It will be 48.30.
Excellent, Mariam. Excellent. Question number 4, last one.
Question number 4, I will get
the same way of question number 3, but instead we calculate iron only. We are going to calculate carbon, then hydrogen and oxygen, right?
Yes. Yes.
Okay, try to explain.
First, I will get the molar mass of glucose. It will be 180 gram.
Yes.
Then the mass of carbon, then the mass of hydrogen, then the mass of oxygen. Then I will get the weight. Then I will get the weight percent of each of them, of carbon, and hydrogen, and oxygen.
What about the number of carbon atoms in this molecule?
The carbon atoms?
Yeah.
Okay, so anyway.
What is the number of carbon atoms in glucose?
6.
6, excellent. So 6 times 12, as its atomic weight.
Yeah, 6 times 12.
And what about the number of hydrogen atoms?
The hydrogen is 12.
12 times?
It will be times 1.
Excellent. And oxygen?
6.
Times?
16.
Excellent, Mariam. So, what about the weight percentage of each element?
The carbon will be 40%. The hydrogen will be 6.7. By approximation, it will be 7. The oxygen, it will be 53.3.
Okay, but we are not going to make approximation, because after finishing this problem, if you calculated all percentage, must be 100%. But if you made approximation, so it will be more than 100%.
Okay.
Do you understand me?
Yes.
Okay, so weight percent of carbon will be 40%, and weight percent of hydrogen will be 6.7, exactly 6.7, not by approximation, to be 7. And weight of oxygen will be 53.3. So after calculating all this product, will produce 100% exactly. So you are right.
Okay.
Okay, Mariam. Any problem till now?
No.
Okay, let's begin the new part. Chapter 3, solution, acids and bases. Okay, it's this lesson. This lesson approximately as the theoretical one, not mathematical as the previous lesson. Okay.
Okay.
Lesson 1, which is called solution and colloids, and I think that you studied some of this lesson in the previous year, middle 3, I think. Okay, so, yeah, I know. Okay. So we are going to make a revision for this part first, okay?
Okay.
Okay. So first, when we add salt or sugar to water, they dissolve in it, forming homogeneous mixture, okay? Can you explain what's meant by homogeneous mixture?
Something that I don't know.
Okay. Does homogeneous mixture can be distinguished or not? Can be distinguished or not means that I can differentiate between its component or not.
Okay.
Homogeneous, I can't differentiate between its component as water and salt. What happens if you get amount of salt or sugar, then mixturing in amount of water? Okay. Can you see the sugar particles or salt particles?
No.
So it's called homogeneous mixture. Okay.
Okay.
But if we put them in gasoline or kerosene, what happened?
I can differentiate them.
Yeah, you can't differentiate between them. So sugar or salt don't dissolve in any of them, and they don't mix.
Yes.
And we can't distinguish between its component by naked eyes. So they call the non-homogeneous mixture or heterogeneous. Heterogeneous, non-homogeneous, okay, non-homogeneous or heterogeneous as this. Okay, this is called first homogeneous.
This is called homogeneous.
And okay, as solution. As what? As
Solutions.
Okay, but the other called what? Called the non-homogeneous mixture. Non-homogeneous mixture, which can be called as suspension.
Suspensions.
As what?
Suspensions.
As suspension. Okay. Any problem till now?
No.
So try to read this paragraph, please, Mariam.
Okay. When we add salt or sugar to water, they dissolve in it, forming a homogeneous mixture called solutions. But if we put them in gasoline or kerosene, they don't dissolve in any of them. They don't mix, and we can distinguish their components by naked eyes. Such non-homogeneous mixtures are called suspensions. So
Okay.
mixtures have the properties.
Yeah, complete. Okay, complete.
Some mixtures have the properties of both solutions and suspensions. They are called colloids: milk, mayonnaise, aerosols, hair gel, blood.
Aerosol.
Aerosol. Okay.
Hair gel and blood. Okay. So
Yes.
so we have first we have two types of mixture. Homogeneous mixture that we can't differentiate between its component as sugar or salt in water. And
Yes.
in the other hand, we have non-homogeneous mixture or heterogeneous mixture that we can differentiate between its components as what? As sand in water, okay, as as clay in water. We can distinguish between its components, so they called suspension. So we have solution and suspension. Between solution and suspension, some mixture that have the properties of both of them, both of solution and suspension. So they are called colloids. Colloids as milk, mayonnaise, aerosols, hair gel, blood. Okay?
Okay.
So this is water and oil called suspension because oil doesn't dissolve in water, but it will float on each surface. Okay? This is milk called colloid that has both properties of solution and suspension. So first, this is cobalt chloride solution. Cobalt chloride solution. Okay? That we are going to differentiate between them. First, solution. What are the importance of solution? Try to read, please.
They are essential for the biological process inside living organisms. They are important for the occurrence of some chemical reactions. The substance forming solutions are regularly distributed in all the solution parts.
Yes. So, essential for biological process inside living organisms. Important for the occurrence of some chemical reaction. Forming solution are regularly distributed in all solution parts. So solution can be defined as a homogeneous mixture of two or more substances. Homogeneous mixture of two or more substances. So what's meant by solution?
Solution, a homogeneous mixture of two or more substance.
Yeah. Okay. After that, the substance which exist in greater amount. What are the two substances which form solution? One of them called solvent and the other one called solute. So what is difference between solvent and solute? What's difference between solvent and solute? Okay. I give you example. If you have mixture as salty water, so it consists of salt and water, right?
Yes.
Which substance has large amount?
The water.
Excellent. So it's called solvent. And which substance which has small amount?
The salt.
Excellent. So can be called solute. Which substance that dissolve in the other substance?
The salt dissolve in water.
Excellent. So salt also called solute. Which substance that dissolves the other one?
The water.
So it's called solvent. So I think that you defined both solvent and solute. Solvent, solvent is substance which is found, solvent, substance which is found with a large amount in which solute dissolve. Solute, substance which is found with small amount that dissolves in solvent. Dissolves in solvent. Okay, do you understand me?
Okay. Yes.
Any problem till now?
No.
So try to read the meaning of true solution and this paragraph.
Okay. True solution, a homogeneous mixture of two or more substances. The substance which exists in greater amount in solutions are called solvents, while substances that exist in smaller amounts and dissolves in water and in solvents are called solutes.
Solute, yeah.
Solutions
So,
are solutions are
solute,
classified
okay,
according
thanks.
to.
Thanks. Solution are classified according to physical state of both solute and solvent into. Okay, there are gas solution, liquid solution, and solid solution. Gas solution, we agree that any solution consists of solvent and solute, right?
Yes.
Yeah. So, example, solvent type gas and solute type also gas. So gas in gas, as air, as natural gas. It's called gas solution that consists of gas in gas, right?
Yes.
There are another gas solution, but liquid in gas, as water vapor in air. Water vapor in air. So it's called liquid gas solution, or gasoline.
Yes.
Gasoline mixture in air. It's called liquid gas solution. We have solid gas solution as naphthalene in air. Naphthalene, small particles that okay, that float in air. So it's called solid gas solution. Okay. Gas liquid as dissolved oxygen in water, right?
Right.
Dissolved oxygen in water that aquatic creatures can respire from water by their gills.
Yes.
Another example, fizzy drink or soda drink as Pepsi, as in liquid. Okay, as if you check it many times, so what happens? I think it will make effervescence. Okay.
Yes. Okay.
This effervescence due to the presence of carbon dioxide gas in Pepsi as shape of carbonic acid, H2CO3, that can be ionized easily into H2, H2O, and CO2. Can be decomposed easily. H2CO3 into H2O, and CO2 evolves up. Okay. Liquid as alcohol in ethylene, alcohol in water, liquid, ethylene, okay, glycol in water, ethylene glycol in water, okay, anti-freezing, liquid in liquid.
Okay.
Solid liquid, it's very easy, as salt or sugar in water. Gas in solid, hydrogen in palladium and platinum. Hydrogen in palladium and platinum. It's gas solid. Silver amalgam, liquid solid. Silver amalgam as silver, K, silver, and mercury, K, in solid. Solid as alloys, nickel chrome alloy, copper gold alloy, stainless steel alloy. All these are called alloys that consists of solid. So it's called also solution that consists of solid mixture. Okay, Maria?
Okay.
Okay, try to repeat it again, please. What about the examples of solution?
Okay. Gas solution, air and natural gas, gas and the liquid, water vapor and air, or gasoline mixture
Mariam,
and air.
it's called gas. You must begin with solute, because solute that dissolves in solvent. So you must say gas solution, liquid gas solution, solid gas solution, and so on. Okay? Okay, complete.
Solid gas, naphthalene and air. Gas liquid dissolved in dissolved oxygen in water and fizzy drinks. Liquid alcohol in water, ethylene, all glycol, antifreezing and
ethylene
water.
glycol. It's called ethylene glycol in water.
Okay.
Okay, complete.
Solid liquid, salt of sugar in water. Gas
salt
solid
or
hydrogen.
sugar. It's a mistake. Salt or sugar in water.
Okay. Gas solid hydrogen and palladium and platinum. Liquid solid silver amalgam. Solid alloys like nickel chrome alloy.
Okay, excellent, Mario. Some important concepts. Okay, so we have electronegativity. Okay, do you remember the meaning of electronegativity?
Yes.
Yeah, what's meant by electronegativity? We studied it in middle 2, if you remember.
Yes.
In periodic table.
It's when the atom attract the electrons.
Yeah, so it's the ability of atom to attract electrons. So if you remember, which element that have highest electronegativity, non-metal or metal?
Non-metals.
Excellent, non-metal at the right side of periodic table. So what's meant by polar bond? Polar bond.
A type of covalent bond between two atoms in which electrons are shared unequally. The greater atom carries a negative charge.
Carries a negative charge, polar bond. Okay, this polar bond. Okay, type of covalent bond. And polar molecule.
A molecule which has a bond carrying molecular positive charge and another one carrying molecular negative charge.
Yeah, it's polar molecule. A molecule which has a bond carrying a molecular positive charge and another one carrying molecular negative charge. Okay. This example. The bonds in water molecule are polar. Why? Because the negative charge or electronegativity of oxygen, as we said before, is greater than that of hydrogen, because oxygen gas, okay, or oxygen element is found at the right side of periodic table, while hydrogen gas is found at the left side. And we said before that non-metals, which are in the right side of periodic table, have highest electronegativity. Thus, oxygen atom carries molecular negative charge, because it has highest electronegativity than hydrogen. So it will attract oxygen, it will attract hydrogen gas to its atom, while hydrogen gas in this case carry molecular positive charge, but not directly positive charge. Okay, as you can imagine that if hydrogen gas has a positive charge, so the hydrogen gas will lose electrons. No, not by this way. Okay, because hydrogen and oxygen, both of them are non-metal, but the difference between them that oxygen gas has highest electronegativity or higher than hydrogen in its electronegativity, right?
Okay. Yes.
So try to read why the bond in water molecules are polar.
Because the negative charge, electronegativity of oxygen is greater than that of hydrogen. Thus, oxygen atom carries a molecular negative charge, while hydrogen atom carry molecular positive charge.
Okay, so the angle between the two bonds of water molecule equal 104.5. 104.5.
Yes.
This is this oxygen molecule, oxygen atom, joined with two hydrogen atoms to form water molecule. So the angle, this angle between the nucleus of oxygen
Is
and
104.5.
nucleus of both two hydrogen will be 104.5. What do you say?
104.5.
Yeah, 104.5 is the angle between the two hydrogen atoms in water molecule. We have definition which is called electrolyte. Okay, electrolyte
Okay.
and non-electrolyte. Electrolyte and non-electrolyte. What's meant by electrolyte? Electrolyte,
Substance.
as if you put sodium chloride in water, what happens? What happens if you
Why?
put sodium chloride in water?
Sodium chloride. It's NaCl. Sorry, I thought only sodium. It will dissolve. It's soluble in water.
Right, dissolve. But does sodium chloride change completely into ions, or some of sodium chloride will change into ions, or can't be changed into ions?
It will be changed into ions.
All or some of them?
All.
All, excellent. All, because it's a strong sodium chloride, a strong salt. Allah Allah. Wait, Mariam. Allah. So all ions of sodium chloride will be ionized completely. Sodium chloride will be ionized completely into positive sodium ion and negative chlorine ion. Positive sodium ion and negative chlorine
And
ion.
chlorine ions.
Okay, so
Okay.
it will be electrolyte. An electrolyte can be defined as substance whose solution can conduct electric current via the movement of free ions, because it has free ions. So it has free ions, it will be electrolyte, good conductor of electricity. Okay.
Okay.
Electrolytes are divided into two types. We have strong electrolytes and weak electrolytes. Strong and weak. What are the difference between them?
أقولهم؟
No. Strong electrolytes that completely dissociate can be said as disassociate or dissociate in water.
Okay.
As all their molecules dissociate into ions, which makes them high conductor of electricity. It's called strong electrolyte as ionic compound. Sodium chloride, sodium hydroxide, polar covalent compound as hydrochloric acid. It conducts electricity of its solution, not in gas state, because hydrochloric acid, okay, can be shaped as two physical state, either liquid can be called hydrochloric acid, and the other hand will be gas, okay, hydrogen chloride gas. So now we talk about the HCl in a liquid state. Polar covalent compound as hydrochloric acid, HCl. It conducts electricity if it's a solution, not in gas state. As when hydrochloric acid dissolves in water, positive hydrogen ions are produced and bond with water molecules, forming what's called hydronium ion. This equation, HCl
plus
gas
H2O
plus H2O liquid will produce H3O hydronium ion plus Cl negative. So it's called strong electrolyte, right?
Yes.
Okay, try to repeat it again, please.
From which part? Strong electrolyte?
Yeah.
Okay. Electrolytes that completely dissociate in water. All their molecules disassociate into ions, which makes them high conductors of electricity. Examples of ionic compounds: sodium chloride NaCl and sodium hydroxide NaOH. Polar covalent compound hydrochloric acid HCl if conducts electricity if it's a solution, not in gaseous state. When hydrochloric acid dissolves in water, positive hydrogen ions are produced and bond with water molecule forming hydronium H3O. HCl plus H2O equal H3O plus Cl.
Excellent, Maria. It's according to strong electrolyte. What about weak electrolyte? Okay, weak electrolyte, sure, it's opposite to strong electrolyte, as
Yes.
can be defined as electrolytes that partially, not completed, partially dissociate in water, and small number of its molecules dissociate in water, which makes them low conductor of electricity. Okay, so the main point between weak and strong electrolyte that their particles, if their particles dissociate completely, so it's a strong electrolyte. But if their ions dissociate partially, so it will be weak electrolyte. As what? As acetic acid, vinegar, CH3COOH, ammonium hydroxide, ammonium solution, NH4OH, and water, H2O. Okay, try to repeat it again, please.
Weak electrolytes. Electrolytes that partially dissociate in water. Smaller number of its molecules dissociate in water, which makes them low conductors of electricity. Examples: acetic acid, vinegar, ammonium hydroxide, ammonia solution, water, H2O.
Excellent. What about non-electrolytes? Non-electrolytes means what? Non-electrolytes mean substance whose solution cannot conduct electricity. Why? Because of the absence of free ions. Because they have no free ions, as sugar and ethyl alcohol. okay, sugar and ethyl alcohol. So what's meant by non-electrolyte?
Substance whose solutions cannot conduct electricity because of the absence of free ions. Examples: sugar and ethyl alcohol.
Or
Ethanol.
ethanol. Yes, excellent. So after that, this is called dissolution. What about dissolution? Okay, dissolution. Dissolution process is a process in which solute molecules dissociate into negative ions and positive ions, or separated polar molecules and then get surrounded by molecules of solvent. So it's called dissolution process. As polar and ionic compound can dissolve easily in water, while non-polar compound as fats, oil, methane don't dissolve in water, but they dissolve in benzene. Dissolve in benzene. Okay? So,
Okay.
non-polar compound as fats, oil can dissolve in
benzene.
organic substance as benzene. Okay? Which called benzene, it's called non-polar compound. Okay, not in water, because water is a polar compound. So polar compound or ionic compound can dissolve in water, while non-polar compound can dissolve in non-polar compound as benzene. Okay, so what's meant by the dissolution process?
The process in which the solute molecules dissociate into negative ions, positive ions, or separated polar molecules and then get surrounded by the molecules of solvent.
Yes. Complete.
Polar and ionic compounds dissolve easily in water, while non-polar molecules, fats, oil, methane, don't dissolve in water but dissolve in benzene.
In benzene. Excellent, Maria. To know how the solution process occurs, we should know that water molecules are in continuous motion. Water molecules are in a continuous motion due to their kinetic energy. Explain, how can we explain it? When putting an ionic compound crystal, such as NaCl in water, so water molecules collide with crystal and attracts its ions. This process, as we said before, called the dissolution process. But a true solution is composed of regularly distributed ions or molecules whose diameters range from 0.01 nanometer to 1 nanometer. This makes the solution homogeneous and allow light to penetrate it. It's called the true solution. It's called what? It's called the true solution.
Solution.
But when putting little sugar in water, okay? Okay, Mariam, please, Mariam, wait for a while. 1 minute, please. Excuse me, Mariam. So, when putting little sugar in water, the polar molecules of sugar gets separated and bond to those of water by a hydrogen bond. forming sugar solution. Okay.
Okay.
As this is a process of salt dissolution in water. Salt dissolution in water. This is the water particles. Okay, water particles between sodium chloride solution. The process of salt dissolution in water. Okay, right?
Okay.
Okay, try to read this paragraph.
Okay. To know how the dissolution process occur, we should know that water molecules are in continuous motion due to their kinetic energy. When putting an ionic compound, the crystal, such as NaCl in water, water molecules collide with the crystal and attract its ions. This process is the dissolution process. A true solution is composed of regularly distributed ions or molecule whose diameters range from 0.01 nanometer to 1 nanometer. This makes the solution homogeneous and allows light to penetrate it. When putting little sugar in water, the polar molecules of sugar get separated and bond of those of water by hydrogen bond, forming sugar solution.
Okay, right. This is called the solution process. The solution process can be controlled by what? The solution process can be controlled by surface area, stirring, and heat. Okay, surface area, stirring, and heat. So how does oil dissolve in benzene? How? Both oil and benzene are polar compound whose bonds are weak. So when we add oil or benzene, the molecules of oil spread in the molecules of benzene. Okay, so benzene, so oil can be dissolved easily in benzene. Okay, as if you have oil, if you have oil on your t-shirt, okay, or your chemise, what happens? Can you remove this oil by water or by benzene?
By benzene.
Then by benzene, then fire. Okay, so what happens after putting benzene oil? What happens beside fire? Yeah.
The oil will dissolve in benzene.
No, chemise will change into black only, but you can wear it again, right?
صح.
But in a black color. Okay, Mariam, we are going to stop in this part and we are going to complete, okay, to not be large information, okay? So we are going to stop in solubility process and we are going to complete, inshallah, next Thursday, okay, in this part. Okay, Mariam?
Okay.
Do you understand well? Any problem?
No.
Okay, Mariam. Okay. Thanks, Mariam. Thanks. Okay. Goodbye, Mariam. I will record this session, okay? Then I will send to you tomorrow, inshallah, okay?
Inshallah.
Okay, thanks, Mariam. Goodbye, Mariam.
Bye.